Okay, now what we want to do is we want to determine if these solids are similar to each other. Okay? Now, one thing we can pretty well be assured of, or we can be assured of, if their measurements are proportional, then their angles are also equal. Okay? So let's look at proportionals. We got a 10 here is to a 5 equals a 6 is to a 3 equals an 8 is to a 4. Now it's pretty simple for us to determine what? 10 is to 5 as 2 is to 1 equals 6 is to 3 as 2 is to 1 and 8 is to 4 as 2 is to 1. Now, since all three of those measurements or linear measures are of the same proportion, we would say that these two are similar. Okay? So those two solids are similar. Now, on these two, we have critical measurements of the radius and the height. So let's look at them. From the small one, the radius of the first, 1 to 4, is that equal to 5 is to 12? That doesn't work, does it? 1 to 4 is not 5 to 12, is it? So these two are not similar. Okay? It's just that simple. If their proportions are equal, if all the proportions of their corresponding critical linear measurements are the same, then it is. This would have to be, in order to make this that, it would have to be, in order to equal that, this would have to be 3 over 12, wouldn't it? Well, that's just not getting there, is it? Okay, 5 is to 12 is just not the same as 1 to 4. Okay? All right, now let's look at the scale factors or the ratios of each of them. Okay? Let's look at these and see what we can determine. If this is a linear measurement right here, what is their surface area? 2 squared as to 1 squared. What's their volume? 2 cubed as to 1 cubed. Well, this equals what? 4 to 1. What does this equal? 8 to 1. So that means this one holds 8 times more than this one does. This one has 4 times the surface area as this one does. Okay? And we can't determine anything on this one, but that's what the volume and the surface area ratios will do for us, is we can immediately determine how much more volume does this hold than this one. 8 times. Why? Because the ratio is 2 to 1 on their linear measurements. Therefore, when we calculate the volume, it's going to be a 3. 3 raised to the power of 3. 2 cubed to 1 cubed. Well, 1 cubed is just 1, so that's going to be 8 times. The surface area, this takes 4 times as much material to make, or surface to cover, 4 times the paint, whatever you need to put there, okay? Okay, now let's look at these linear measures and surface area and volume ratios we talked about at the beginning. We have 2 spheres. Now, let me ask you this question. Are spheres similar? Can you find me one sphere that is not similar to another sphere? Can't be done, can it? Definition of sphere. Collection of all points, equidistant from one point. The only thing that's different between spheres is how far away the points are. Therefore, all spheres are similar to each other. Don't have a choice. They're going to be similar. If the radius is equal, same unit of measure, then they're going to be congruent. These two are obviously not equal. We have a radius of 3 and a radius of 4 on this one. Their linear measure, the ratio of this one to this one is 3 to 4. What's their surface area? What do? We square each one. That makes it 9 to 16. Okay? Look at the volume. We cube it. 27 to 64. Okay? This one, barely over 1, okay? This one, almost 2 times the surface area. This one, more than twice the volume. This holds more than twice what this one will. Let's look at some cubes. Again, I'll ask this question. Do cubes have any chance of not being similar? No. Cubes are similar. Why? Because they're cubes. All the dimensions are the same. It's just a matter of how big that one dimension is. So all cubes are going to be similar. It's just a matter of how big. This is a 7 by 7 by 7 cube. This is a 4 by 4 by 4. So linear measures, 7 by 4. This one's almost twice as big. Okay? Surface area. We squared 49 over 16. This one has almost 3 times, has more than 3 times the surface area of this one. Look at this. Cube. The linear measure to get the volume ratio, 343 to 64. Almost 5.5 times the volume. This one holds 5.4 almost of what this one will hold. Okay? It's not quite, almost twice as big, but it holds 5 times the volume. Okay? That's what we're talking about when we say the surface areas and the scale factors of linear measures versus the surface areas versus volumes. Okay? That concludes our congruent and similar solids.